All right. Hi, everyone. We are once again back into our school term. Um, we are in our last block, and I think according to the calendar, we have about 7 weeks to 6 weeks to complete our material. So, as promised last week, I would look into the warming you up, the revision of where we really left off, with little new things there and there, but very minor, 2% probably, of some of the things that we didn't really cover. But I'll try to cover in this revision block set. All right. Now, the outline of this presentation, we'll do a revision, as I mentioned, on the reference frames, induction machine DQ model, and I'll talk a little bit about the project. Then we will see how far we get. We'll do permanent magnet synchronous machines, introduction, the types of permanent magnet synchronous machines, the DQ reference frames, the permanent magnet synchronous machines, DQ model, and the mechanical derivations. The mechanical derivations are really similar to those of the induction machine. Now, the way we are going to be doing this is I will do about 10 minutes videos. I'll try to time myself so that they're about 10 minutes or so. The reason being, if it is too long, then really it can get difficult to get to certain areas which you might have been confused about. So we will I'm trying to put my timer here, but then it's making a noise. I'll just use time. It's about 9:30 now. Okay, so these small videos we will probably cover. I'll do reference frames, one video on reference frames revision, one video on induction machine DQ model, and then a bit of the project. Hopefully those two will give us 2 videos, and then another video on permanent magnets, introduction, and then types. Every 10 minutes I'll try and separate so that it's based on the title, it's based on the topic at hand, and I'll be able to capture label it in that way. Okay, let's head on into reference frames revision. All right, now we left off really this was 2 weeks prior we did the DQ models, but I come back to it because really understanding the reference frames is key at the understanding the heart of this course. And not only for this course, really, when you go and do power systems studies and so on, or trying to simplify a three-phase system into a two-phase system, or moving from a certain frame to one, it will really help you moving forward in the future. So I just want to recap on the so that you really understand what is this reference frames. So reference frames, right now here, this is a stationary frame. Stationary means you have a machine, it's there, it's stationary, it's not moving. The frame of the machine, what's moving is the rotating is the shaft and all that, but the motor itself is stationary at a particular place. So this is your stationary frame. Now, the theory of reference frames basically means, if I am here in the stationary reference frame, what do I see? What am I seeing when I'm standing here? We actually experience this in our normal day-to-day life. For example, if you are walking towards the only way you can know that you are walking, either moving forward or backwards, is that you continuously compare yourselves with your surrounding area. So if you're moving and you're noticing that the object near you is moving closer to you, chances are you are walking towards it. So you are using it as your reference to judge your movement, and that object is in your same frame of reference, and that's why you can use it. So for example, if you are in a vehicle, the vehicle is moving forward, there's another vehicle that's overtaking you. you it's a bit difficult when the vehicle is overtaking you. It's quite sometimes difficult to know whether you are moving backwards or that vehicle is actually moving, is the one overtaking you. The only way to know is you compare yourself with the stationary frame, which is the ground. You are moving, you're on a moving frame. So the only way you can tell if you're not moving backwards in the vehicle is not moving backwards, actually you're being overtaken, is because when you compare yourself with the objects on the stationary frame, you're moving forward. So chances are this vehicle is also overtaking. So we constantly do that, but it's so subconscious that it's so obvious that we don't even think about it. The other one is if you are standing in a vehicle, sitting in a vehicle, and there's another vehicle in front of you at a traffic light, let's say, and then the vehicle in front starts moving backwards. If your frames are not right, you might actually think that you forgot to step on your brakes. You might think that you're actually moving forward to the vehicle. But the only way to know is when you compare yourself or that vehicle with the stationary object, stationary frame, you begin to see, oh no, it's the vehicle that's actually moving backwards to you. So my point is, it depends where you are to be able to judge what's going on in your surrounding. So for example, if you move from this reference frame to this frame, you are still the same person. It's just that you are now on a rotating frame which is spinning at that speed. The question is, at that frame, what do you see? What are you at that frame? If you move to that frame, what do you see? And this is the power of reference frames. They are able to allow us now, first of all, to reduce a three-phase system on a stationary frame to a two-phase system. Now, depending on which frame you are on, you may be able to be a DC signal now at this frame instead of being an AC signal. We will see as we move forward in this. Or if you've done all your assignments, you'd have noticed that, especially homework 3, that in the synchronous frame, everything becomes DC. So, and it's because you are on a moving frame. You are now rotating at synchronism. Remember, the AC was because of your on a stationary frame, and then the supply was AC. But then if you are rotating with the same frequency of the supply, everything becomes DC. And now this opens the doors for you to be able to implement other methods in that frame. For example, you can do control in that frame, in that DC frame, and whatever you're doing in that frame would be actually taking the same effect on the stationary frame. So this is the novelty of these reference frames, which I would really like you guys to appreciate. And as we mentioned before, the path transformation or the transformation matrix, Kx is the angle you are moving from. So stationary frame ABC, you are moving from the ABC to your DQ X. If you want to move from there to Y, you use theta Y, which is this case. And again, you can move from one frame to the next frame, which we will be doing in the permanent magnet machine. We'll be moving from a stationary frame to a DQ frame. And that stationary frame is actually also a DQ frame. It's a two-phase, but we're moving to another one, to the rotor frame in the DQ. It will be quite interesting. You'll see when we get there. So all that is the thing that makes all this possible is the trigonometric functions. So I hope you are warmed up and you do remember what we covered in this reference frames. Let me look at the time. All right, so I think I'll end this video here on reference frames, and then we will continue with what we had planned, which is we'll go into now the induction machine DQ model. All right.